So on the left hand side you can see guys the question which we have now, and this is basically a simple application of whatever we have done. Now let's come to solution. So solution one, the EMF, induced EMF would be nothing but what? BVL, and you know the reason. All the three are mutually perpendicular, right? Okay. Now I is equal to E by R, which is pretty simple. R plus R, or you can write it BVL by R plus R. Okay. Now let's quickly move to the second portion. Find the acceleration, second portion. So this is first, and let's move to second portion. Second is, the force on the left, would be IBL, you know why. So if you apply a right hand palm rule, right hand palm rule. Okay, now I'm just replacing the value of I from what we got here. So it becomes what? B, square L square V by R plus R. Okay, now acceleration would be nothing but F by M. So we can just write it what? B square L square V by M R plus R. Okay, very good. Okay, now one thing you have to remember is this force is a retarding force because it's trying to stop the rod moving ahead. Okay, so I can write it, acceleration is basically minus of this. Okay, now but what is acceleration? And you know it, right? Acceleration is nothing but dv by dt, is equal to minus b square L square V by M R plus R. Okay, so basically this is what we have written it here. Okay, I've just quickly moved to the next sheet because there was space crunch. So what I was saying is, in the last lecture or in the last slide, what I've written is dv by dt, is equal to minus b square L square V by M R plus R. Further, I can write it like this. I can move there, and this becomes dv by V is equal to, minus b square L square, dt by M R plus R. Okay, now the velocity I am putting from v to v naught, it will get reduced, and time is t to 0. Okay, let me integrate both sides. As you know the integration, it will be what? Log e v by v naught is equal to minus b square L square t 0 and M R plus R. Okay, further I can say, I'm sorry, this is hold 0, so I have to basically write it like this. Okay, now I can write it log E V by V naught is equal to minus B square L square T by M R plus R. Further, V is equal to V naught E minus B square L square T, and I can write it divide by M R plus R. Okay, So now friends, this is, as you see on the right hand side, there are two portions which are remaining of this question. One is, sorry guys, I'm repeating this because there was some mic problem. So there are two portion of this question which are remaining, as you see on the right hand side, fourth and fifth. Now fourth says velocity as a function of displacement x. Now it's very simple. Now what we have done here is, we know that acceleration is equal to minus b square L square v m r plus r. Okay, further I can write acceleration as v dv by dx is equal to minus b square L square v by m r plus r. Now I integrated both sides, or before integration, let me first cancel this, right? Now I can integrate this from v to v naught, and it will be x to 0, correct? So, and we are integrating this b square L square m r plus r, and this dx has gone this side. Okay, now if I integrate it, it becomes what? V minus v naught is equal to minus b square L square by m r plus r, small r, x. So that's it. Take that on the other side. So we will get v is equal to v naught minus b square L square x m r plus r. So this gives you, third part. Now the fifth portion is relatively very simple because we already got the fourth portion. Find the distance covered by the rod before stopping. Very simple. So in that case, just let me use my another pen, but just go here when it before stopping, v is equal to 0. So you can say, if I just substitute it here, let me put it here, fifth would be 0 is equal to v naught minus b square L square x by m r plus r, correct? Or further we can just find the value of x. So x will come m v naught r plus r by b square L square. So this is fifth portion. Okay, so this ends here.